PointSense Pro paneling. In our first section, we'll take a look at how we can get from scene to CAD. Within scene, to create our Autodesk point cloud, all you have to do is right-click on Scans after registration, go to Import Export, and then click on Export as Project. Select the RCP, click on Export, and the creation of the Autodesk Recap point cloud will begin. Once that is completed, you can insert that right into an AutoCAD drawing using our PointSense Pro tools. We'll click on Point Cloud and insert, grab the RCP and click Open. Then we'll scale from meters, which is the units of the RCP or the FLS files, to the units of our drawing, which will be inches. We'll click OK, and to visualize the point cloud, we just go back to Optimize Display here on the point cloud panel. And now we have our point cloud in the drawing. In our next section, we'll look at how our Faro VirtuServe software can connect to AutoCAD. On the right-hand side of the screen, you see VirtuServe, which is our software for viewing each scan position as a planar view image, and on the left you see the point cloud within CAD. Using some of the macros on the right-hand side here, we can communicate commands like the 3D polyline command to send coordinate data and line work over to AutoCAD. Commands can be executed from VirtuServe and then finished inside of CAD, and we can see how that communicates well to the model space there in CAD. You can also begin CAD commands picking points directly off of the point cloud and use that in combination with point selection from VirtuServe to help complete the command. So here I'm just drawing an arc, and then I'll use this extrude last command macro to give that an extrusion height. Section 3, Dimensioning. Using VirtuServe and AutoCAD, we can take dimensions, take distance measurements in VirtuServe with the Measure Distance tool. So for example, I want to get a measurement of the height of the building here. I just measure from one corner to the other, and I end up with the distance measurement here in inches. This is based on our units under Measure Mode and Configure Measurement Unit, which is in inches. And I can also take dimensions directly off of the cloud if I want to, or place 3D distance dimensions using the PointSense 3D distance tool. So if I want to take a measurement from, let's say, this corner to this back corner here, I get a 3D measurement there of 669 inches, again based on the scale of point cloud. And we can, last but not least, use the AutoCAD command for dimension. I'm going to change my UCS here using the vertical UCS tool of PointSense. I just pick 2 points there, and now my UCS is on that wall. Then using the dimension linear command, I pick 2 points. I can pick this first corner here and the second corner there, and now we have ourselves an AutoCAD dimension. Clipping tools and the section manager. On the left-hand side of our drawing, we have the section manager, which can toggle the visibility of the point cloud. And on the sections panel of the ribbon, we have tools for isolating portions of the point cloud. So here I want to focus on my garage. I'm going to right-click, I'm going to rename this and preserve this section so that I can recall it at a later time. I'll go back to all points, and if we would like to isolate the atrium, we have a tool for clipping a circular section. So we'll do define circle, 1, 2, and 3 points, and now those points are a part of my current section, which I can then again rename and call this atrium if I'd like. So clipping tools help us to isolate portions of the point cloud and are view dependent. For more interesting shapes, we have define clipping polygon, and this enables you to clip a shape that has multiple sides, like this window. We just hit enter to close. Now we have that isolated there, which we can rename if we'd like. Section 5, Slicing Tools. Another sections tool that can be used to isolate portions of the point cloud are these slicing tools here. I'm going to use the Define Slice to create a single slice parallel with ground. This is going to help us to create a profile of our building. We'll switch to top view here, and you can see the profile of the building appear there. We'll use line fitting tools in a future video in order to extract the line work. In areas where you may want more profiles, for example, like this atrium, I'll just isolate the atrium section there. We can use multiple slices to generate profiles at different elevations. Going back to sections, slice, and define multiple slices, I just say parallel to a UCS plane, use just the visible section, and go to the next page here, leaving the defaults on that page as well. We're going to pick our slices to be every 24 inches. You can specify the interval you like here. Create a station list and go to the next page. Specify the thickness of your slice, click finish, and after a few moments we'll have multiple slices of the point cloud which we can then digitize using some line fitting tools. Section 6, line fitting. After creating a slice using our sections tools, we can digitize it by using a line fitting tool like Fit Outline Plan. Fit Outline Plan is meant for straight geometry, like the walls we see on the right here, and we just pick 2 points close to the ends of the wall, 2 points on our next wall, and the software fits to those points inside of the yellow region, creating a best fit line. The software also takes care of the intersection corners, so all we have to do is continue picking 2 points until we reach a nonlinear section of our point cloud, which we will use Fit Polygon for. I just hit enter and enter again to complete the command, and now I'll begin with Fit Polygon on this curved portion of the cloud. Very similar to the Fit Outline Plan, we just trace, picking points. As many points as you'd like. The more points that you pick with this tool, the better it will adhere to the cloud. We do have a tool that can add points afterwards for editing if you like. When you get to the other end, just hit enter, and even in that area on the right there where I didn't pick the best point, you'll see that it does adhere to the cloud well. And when we turn off our current section, we have 2 AutoCAD polylines which we can join using standard AutoCAD editing commands like extend. Section 7, plane fitting. Planes can be fit to help you determine edges and corner points. Using the Fit Plane tool, we can use Click Points option to select 3D points from VirtuServe, and we can also combine that with point selection from CAD. Once you have 3 or more points, you can click OK or enter an OK to create a cubit plane, and we'll create a few more planes here. Plane one click can be used to create a plane with one click of a button based on a certain search radius. And you see that also gives us a cubit plane there. The last option for creating planes is using the draw plane option, which you just select points either from VirtuServe or CAD. Best to do that from VirtuServe, and it creates a plane for you. Once you have those 3 planes, we can find the intersection lines between them using the intersection tool here, intersection lines or points, and we can just select our 3 planes and get intersection lines between those 3. Additionally, planes can be used to set UCS, so on the digitizing tools panel of the ribbon, just select UCS from plane. And now our XY plane is on that surface, and you can draw panels if you'd like in that direction on that surface. Section 8, creating elevation drawings using the X-line method. Here inside of CAD, I just need to set up a UCS that will make the XY plane on this wall that I want to create an elevation of. I'm going to do the quick method. There's many ways to create a plane or set up a UCS. I'm just going to do the vertical UCS 2-point method, which creates this head-on view in CAD. I'll now split the screen with VirtuServe, use the XL vertical macro, and pick a point on every wall that will be parallel with the Y-axis here in CAD. So I'm going to pick a point on this wall and also a point on this wall, and I'll have to do some trimming afterwards, but here I'll go XL horizontal. I'll pick a point at the top. I'll pick a point the ground, but we can see that that's kind of sloping, so we may want to use this XL angle instead, which just allows us to create this infinite line, the X line or construction line, at an angle. We can do the same thing here, XL, 1 and 2, and now that we have all of our sides, we can just use good old AutoCAD trim to just tidy this up here in CAD. And we'll just trim a bit more here. And there you see we have an elevation just using the XL macros from VirtuServe. Section 9, creating elevation drawings using the fit outline plan method. Using the same UCS that we set up previously, which is on this wall, we're going to create an outline or a elevation of this wall. I'm going to take a slice first, so go define slice in XY plane, and I'm going to pick 2 points on this wall that is perpendicular to my wall. I get an outline of a portion of the wall, and I can begin with the fit outline plan tool on that side. So I'll pick 2 points on that right side. I pick 2 points on the next side here, and it connects the lines for me. I pick 2 points on the next wall. I can do 2 points here on the ground, and then we don't have any points on this side, so we can turn fitting off, and we're going to pick, with our 3D point macro from VirtuServe, we'll pick 1 point closer to the ground, 1 point closer to the top, and you see we get that blue line, which means that it's based on our point selection, the way this line is being drawn. On the top side here, I just pick 2 points. It's okay to pick them against the sky, and that way I don't select a point behind, like if I were to try and select this edge here. Then, since I've gotten back to where I started, I just use the close button down here in the command prompt, and we see that we have an elevation view there